All right, let's talk some probability. This video is going to help us understand what it means to count up possible events and also define what the probability of those events are. So the first thing that we need to be able to do, again, in order to do math, we got to be able to speak math. So we've got to understand what we're going to be talking about. If we're talking about the outcome of an experiment, basically that's the possible results of the experiment. The outcomes are actually what can happen. So when we're talking about flipping a fair coin, we're talking about coming up heads or coming up tails. Right? If we're rolling a dice, we're saying, okay, the outcomes are the 1, the 2, the 3, the 4, the 5, or the 6. Again, an outcome is what can happen. A sample space is the set of all possible outcomes, so to literally list off all of those outcomes. Now, most of the time when we're talking about counting and probability, we're not that worried about what the individual outcomes are or what the sample space is. What we really want to know is what can happen when we do a certain event, like flipping that coin. An event is an outcome or a collection of outcomes. So how many outcomes can you receive if you flip a coin? Well, like we said, you can either come up heads or tails, which means how many outcomes are there? Well, technically, there are 2 outcomes. Rolling a 6-sided dice or number cube, well, it kind of says it in the name. There are 6 different things that can happen. So basically, there are 6 events available. Now, how many possible outcomes are there if you roll a 6-sided dice, then flip a coin? So we're sort of putting 2 events together. Now, we could draw this all out in various different ways, and we'll talk about one of those ways in just a second here. But one thing that we want to recognize is that there is what we call the fundamental counting principle. The counting principle says that to count the number of ways the 2 events can occur, so flipping our coin and rolling our dice, all we have to do is multiply the size of the sample space for the first event by the size for the second event. So basically saying, well, we could get either heads or tails, but we could also, if it comes up heads, get any one of the 6 numbers on the dice, or if it comes up tails, get any one of the 6 numbers on the dice. Or 2 times 6 means there are 12 possible things that can happen if we flip the coin, heads paired up with 1, 2, 3, 4, 5, or 6, and roll that dice, or tails paired up with, again, the 1, 2, 3, 4, 5, 6. So again, there are 12 things that can happen. That counting principle is very helpful. Now, one way to explain the counting principle is to talk about what's called a tree diagram. So we have a little bit different event going on this time. Find the probability of getting 3 heads in a row if you flip a coin 3 times. Well, the tree diagram can represent, again, that sample space. What are the possible outcomes? What are the things that can happen, right? If we're going to try to list these things off, what are the things that could happen if we flip that coin 3 times? Well, the first flip can come up either heads or tails. And then from heads, we could either be, again, heads or tails on the second flip, or if the first flip was tails, we could be heads or tails on the second flip. So again, it's a great way to represent, okay, well, there's 4 outcomes for heads and tails, or tails and heads. And then finally, if we flip that coin a 3rd time, basically we could just follow the path in order to list off our events. Otherwise, it might be hard to recognize, did you write them all down or not? We might get those H's and T's kind of confused. But if we list them all off, we've got heads, tails, tails, heads, right? We've got all these things listed off down here. So again, find the probability of getting 3 heads in a row if you flip the coin 3 times. Well, that only came up 1 time. Only one of these routes or one of these paths, one of these scenarios is all 3 H's. So basically the probability of that now says, well, how many ways can that happen? Well, there was 1 way that our event can happen out of, and again, this is why we need to know the size of that sample space, the 8 different events, right? 1, 2, 3, 4, 5, 6, 7, 8. Or remember we had 8 finishes, right, at the end of our factor tree there, or our tree diagram, I should say. So again, we have 1 of the 8 possibilities is going to be heads 3 times in a row. The theoretical probability of something happening is the number of favorable outcomes. What do you want to have happen? Heads 3 times in a row. divided by the total number of outcomes. Again, there were 8 possible outcomes that could happen. So 1 divided by 8. And again, you could write that as a decimal. Again, every probability of an event always is a number somewhere between 0 and 1. And 1/8, or basically 0.125, is definitely between 0 and 1. It's the measure or likelihood, or the chance of something happening, right? The chance of an event happening. Again, it can be expressed as a decimal, we can express it as a fraction, or sometimes even as a percentage. Again, we could have written that as 12.5%, right? We would move that decimal 2 spots, and again, we could write it that way. Since the problem didn't say so, I would take the answer any one of those 3 ways. Well, we'll find the probability of getting 1 tails total if you flip the coin 3 times. Well, notice I've got it highlighted for you here already. Again, the 3 different scenarios, we could have had tails last, or second, or first. Basically, there are 3 ways out of the 8 ways that can happen. So 3/8 would be our theoretical probability. Again, what do you want to have happen versus what could happen? Let's think about this scenario. You're going to roll a fair 6-sided number cube. Basically, you're going to roll a dice. What is the probability of rolling a 4, rolling an even number, rolling a multiple of 3, or rolling a 1, a 4, or a 5? And we'll talk about that word "or" more here in just a minute. Go ahead and think about these problems, though. What do you think the probabilities would be? All right, do my answers match up with yours? Again, the probability of rolling a 4, well, 4 is one of the possible things that can happen. So again, 1 out of the 6 possibilities. What do we want versus what could happen? Probability of rolling an even number, well, there are 3 even numbers on a dice, right? There's a 2, a 4, or a 6. So if there's 3 possibilities that we want out of the 6 possibilities that could happen, our probability is going to be 1/2, 0.5, or 50%. Of rolling a multiple of 3, well, again, there's 2 possibilities. 3 and 6 are both multiples of 3. So 2 things we want out of the 6 things, that's a 1/3. And finally, of rolling a 1, a 4, or a 5. Well, the probability of rolling a 1 is 1 out of the 6 possibilities. We already said the probability of a 4 is 1 of the 6 possibilities. And the probability of a 5 is 1 of the 6 possibilities. One major thing that I want you to remember is that typically when we're talking about probability or counting, if we see that word or means add. So we're going to take the probability of a 1, add it on to a 4, add it on to a 5. There are 3 things that we want to have happen, or that could happen, that we're okay with. 3 favorable events out of the 6 possible events that could happen. And again, the probability will be 1/2. Now, theoretical probability is very helpful, but experimental probability is just another way of looking at things. Experimental probability says we're going to have a number of trials of an experiment that's going to happen, and there's going to be a number of successful or favorable, again, the events that we want to have happen. Well, the experimental probability is the number of successes, the things we want to have happen, divided by the total number of trials. So again, we're going to flip a coin. Now, normally we would think a coin can happen 50-50, but that's theoretical. If you flip a coin 25 times and you receive tails 8 times, what is the experimental probability of tossing heads? So in one toss, again, normally we would think 50-50, but we already know that this coin tends to come up heads far more often. We only got 8 tails out of the 25 times that could happen. So what's the experimental probability of tossing heads? Well, there's 2 ways to look at this. Number 1, we could just take our 25 possible times it happened, subtract off the 8 tails, because if it didn't come up tails, then it must have come up heads 17 times. So therefore, we would say probability of tossing heads is going to be 17 out of 25 times. Now, another way to look at that is use what's called the complement. Okay, the complement of an event. There are 100% of the things that could happen, and if we subtract off all of the ways that tails came up out of the 25 times. So the probability of tails, well, 1 minus the probability that it came up tails, and that's kind of what we call probability notation. P of t is a way to represent the probability of t, of tails. Well, 100% of the things that can happen minus the probability that the tails happened is the probability of everything else, which for this idea would have to be heads. Well, 1 minus 8/25, again, just comes up 17/25. So again, that's another way of looking at it. That's called the complement. Complement of an event. There you go. All right. Tell you what, let's try this one out. How about we talk about a spinner? If you had a number spinner, so you take your finger and you twirl it around there, right, and it comes up with a number. For the wheel at the left, there are 10 numbers hidden underneath this black spinner here. If you spin the wheel, what's the theoretical probability of landing on a multiple of 3? Again, remember that they're numbered from 1 to 10. And then also, if you spun the wheel 15 times and an even number came up 6 times, what's the probability, the experimental probability, of spinning an even number? Think about those ideas, and then we'll talk on the bottom here about what it is to find the odds of an event. Okay, well, there are 3 multiples of 3 underneath. There's 3, a 6, and a 9. So there are 3 of the 10 items, or basically 0.3. For the experimental probability, well, again, if the even number came up 6 out of 15 times, then 6 over 15 is the experimental probability of spinning an even number. Again, remember to reduce that fraction, so 2/5, or you could always put it in decimal form, 2/5 being the same thing as 0.4. Now, at the bottom, one thing that's often confused with probability is what's called the odds of an event. However, in math, that's technically different. The odds of an event are the number of favorable outcomes, what we want to have happen, divided by the number of unfavorable, the number of things we don't want to have happen. So not like on the top where we said, well, there's 3 things we want out of 10 things that can happen. Now we're saying, what are the things we want out of the things we don't want? So again, the odds of an event, the odds of spinning an 8 on our spinner, well, there is one thing that we want. We want to spin that 8. But again, there's 10 total items. If we already are saying we want the 8, then that means there's 9 items we don't want. Or what is often written as 1:9. Again, you can write that either way when you're talking about odds. 1 to 9 is saying there's one thing we want versus 9 things we don't. So again, the odds of spinning an even number, well, half of the numbers on our spinner are going to be even, right? 2, 4, 6, 8, and 10. So again, there's going to be 5 items that we want. There's going to be 5 even numbers, again, that we want. There's going to be 5 odd numbers that we don't. Or basically, this becomes 1 over 1, or a 1-to-1 odd, or odds. Finally, the odds of not having something happen, well, we just flip that over. The odds of not spinning a multiple 3 is saying, well, the unfavorable things, how many things are not multiples of 3 versus how many things are multiples of 3. So we're just going to flip our fraction over. We know from the top, again, there were 3 multiples of 3 up here. So we're going to go down here and say, well, there's 3 things that would have been multiples of 3, but that means that there are 7 that are not. Or basically the odds of not spinning a 3 would be 7 to 3. I hope that helps you with theoretical probability, experimental probability, and the odds of an event. If you have any questions, make sure you talk to your teacher. Otherwise, have a great day